that should now be recorded. And I give the word to Anouk.
Okay, thank you, Til. Let me start by trying to share my screen. All right. Okay, so I guess you can see my screen right now, right?
Yes, but yes, very good.
Okay, good. Yeah, because my team sometimes is acting a little bit weird. So if anything's going wrong, please let me know. Okay, now I can also see your faces. That's nice. Well, first of all, thank you all for watching the colloquium today. As Til mentioned before, my name is Anouk Nerings and I'm in the Human-Centered Computing group. I started my PhD last November, and today I'm going to give you a talk about my PhD topic, which is about social robots for child and family care in the Netherlands. Yes. Okay, so first of all, why would we want to use social robots in child and family care? Well, social robots can actually increase engagement, self-discipline, and self-awareness in children, which are all important aspects in all types of treatment. Also, social robots have technological abilities that can help the professional in his work, for example, by playing educational games, or also by providing information in a multimodal way, for example, at a little video clip on the screen, or by using gestures and voice. And related to that is that robots are also intuitive to communicate with, which is especially important when you're talking with children, or maybe not able to read yet, for example, but also with parents who have difficult backgrounds, like other language skills, for example. But how should we actually use them in this context? That's the main question here. So to answer that, first we came up with some scenarios. A social robot could perhaps help in one-on-one child and professional conversations to break the ice. But professionals are actually using toys right now to do this, but the social robot might be even more valuable, but we're not sure about that yet, so we should test that as well. And also social robots could be used to carry out standardized tests. So the child could fill in, for example, an intelligence test with the robot, which would make it more fun for the child and keep the child more engaged as well. So to investigate this further, we started a collaboration with the CEG in Capelle aan de IJssel. CEG stands for Centrum voor Jeugd en Gezin in Dutch, which means Dutch Child and Family Center. So for our target group, we are looking at children of the age 8 to 12. And the reason why we do this is the biggest client group of the CEG. And also because these children have a different variety of problems, if I can call them problems. For example, autism or atypical developments or family issues, but also more physical health related things like vaccinations. So to do this, we set up a participatory design project, which means that we include all stakeholders from the beginning of the project. And with stakeholders, I mean professionals working at the CEG, parents, but also teachers at primary school and the children themselves. Right now we are still in the exploration phase, where we are doing focus groups to define the robot requirements. And we also plan to do observations of child-robot interactions in current low-risk implementations. For example, at the mass vaccination days, currently there is a robot going around showing the children what the procedure will be of the day. And later on, we will go on to the testing phase, where we will systematically test the requirements of robot behaviors that we find in the exploration phase in realistic settings. So for example, on location of the Dutch Child and Family Center, but also on primary schools. And my main research question regarding my PhD here is, how is the child-robot communication the most effective in a youth care setting in creating a setting of safety and trust where the child feels comfortable enough to be honest about important aspects? So we already did some focus groups, so we have some preliminary results, even though they are still being analyzed. Okay, let me use my pointer here. Here on the left, you see some example requirements from the focus group with professionals, while here on the right, you see some requirements that we found in the parent focus groups. As you can see, some requirements are really similar or perhaps even the same. For example, it is needed to create a support base, which for the professional means that the professional needs to be needs to know how to use the robot beforehand, but also during the use of the robot. This picture is actually a good example of this. Maybe the robot could be even able to explain itself what it can do at a certain moment in the context. And for parents, this means that they express that there's more knowledge needed about the possibilities of robots, and also to increase the knowledge, experimental research is needed, but the parents need to be informed about it as well to support the treatment. Also, since every child is very different, also in our group of children aged 8 to 12, if your age is also really different than when you're 12 years old, for example. So the robot needs to adapt its behavior on this as well. Of course, the robot should be safe to use, not only regarding design, but also regarding data processing, especially in this sensitive childcare context. And the robot should be a tool and could never replace a professional because it lacks certain human skills that are necessary in the treatments. Also, the professionals mentioned that it is especially important for a robot to process not only verbal information, but also non-verbal information, because children sometimes find it difficult to express how they're feeling, and the robot should be able to respond appropriately to this, and maybe should even be able to notify the professional if anything unusual is going on. While the parents said that the robot should be more of a neutral party, because that would make the child feel more comfortable. If the robot is non-judgmental, they can just say anything to it. So for the future plans, we plan to do some observational studies at the Dutch Child and Family Care Center to look more into the work that they are doing and see where the robot could be deployed. Also, we will observe effects of the social robot in current low-risk implementations like the mass vaccination days. And later on, we will go on with co-designing with stakeholders, including the children, for which we will use special methods. And we will also do experiments at the Dutch Child and Family Care Center and at schools to test the different designs that we come up with and systematically test each requirement. So this was my talk for today. If you have any questions, let me know. You can also always send me an email. Thank you.
Okay, many thanks, Anouk. Yeah, so I guess now we take questions. So I guess when you have a question, the easiest thing for me would be to either raise your hand or just unmute yourself, shows your camera, and speak out the question. For me, maybe to break the ice, maybe I start with a question. So you showed these pictures of this robot, and I guess this machine physically exists, right?
Yes. Yeah, I didn't tell you. I actually showed you some example designs. And this one, I think you can still see it, the iPal, that is the robot that they currently have. But it might be even more useful to also use the Pepper robot, for example, that we have, because the Pepper robot has other technological abilities.
So yeah, so what are they currently at the moment capable of doing?
Well, this one is capable of, for example, showing a video clip on the screen, and well, it can in a certain way interact with the child, but not really that good. So mostly a Wizard of Oz method is used, where a professional will type in the responses of the robot.
But okay, so I guess at the moment they can walk, they have a camera, they can produce sound, they can produce picture.
Yeah.
And the software is not that far yet, so they.
Yeah, exactly. Yeah, especially this model is not that good in this sense.
Okay, so I will have more questions, of course, but maybe let's give Imke the opportunity to give a question. Imke, you want to ask something? Or you just want to comment?
No, I want to ask something. I was actually also wondering, because you say you're going to test different designs. So would that then be different things that Pepper could do, or actually, like you said, the different robots, and see which works best, or both, or? Or you don't know
Yeah,
yet?
I think that also depends on the possibilities and also on the outcomes of the focus groups. For example, one parent mentioned that the robot can't be too big because then it's too scary. And the Pepper
Yeah, that's
robot,
what I was thinking with
yes,
Pepper indeed.
and also this one is quite big, so that's why we were thinking of maybe also buying a Now robot, which is this one, which is a bit smaller. Yeah, but we're mainly focusing upon the design of the interactions, to be honest, to clarify that a bit more.
Yeah, okay, no, thanks.
Okay, Shark, you have a question?
Yes, thanks. Nice presentation, nice opportunity for doing research in this context with robots in childcare. And what my question is more, okay, what type of research method are you employing in the sense of are you also creating, let's say, interaction designs for the robot yourself on a particular type of communication, types of interaction with children, and show the effectiveness of them, or are you more interested in the perceived usability, so more from a technology acceptance point of view? Can you comment on that?
I think we plan to do both. Of course, we need to design certain interactions in order to test them. And for me, what would be most interesting is to see which type of interaction is most effective, depending on the context, of course.
So that means also that you'll have to design those interactions, and are you doing that in collaboration with some robot technology provider? I do not see a name. Maybe I missed that. I came in a bit late, but
yeah, I didn't mention that. That's true. Yeah, we plan to ask for assistance at different parties. For example, we hope to collaborate with TNO on that as well.
Oh, yeah. But there is no, is there a software provider developing software for those robots in the Netherlands?
Yes, there is, and we are in contact as well, but we still have to figure out how we will exactly collaborate with them, in what way, yeah.
Okay. And why is that so? You stated in a more funny way. Why is that so funny, or is it difficult to collaborate with them, or?
No, it's not. I don't say. Did I say funny way?
Well, you were laughing when you said it. So.
Oh yeah, no. Yeah, we are in contact with them. That's the only thing that I can say, and we didn't really make that harsh. Yeah,
because
what I mean, nothing funny going on.
Oh, okay. That is. No, I thought your relationship with them was a bit blurred or whatever, but that's.
No, it's just that we only started contact a couple of weeks ago, so.
It's pretty
we haven't
recent.
decided anything yet, so that's why.
Let's maybe give Federica the opportunity to ask a question.
Yes, can you hear me okay?
Yes.
Nice, yes. I was wondering if you have some preliminary results and if you have any promising interactions that you would like to mention.
So you mean like the scenarios that I mentioned at the beginning, for example?
Yes.
Yeah, because what I especially think is that on one-on-one child professional interactions, it could be really helpful to have the robot to make the treatment more fun, to break the ice, and also to make the child feel more comfortable. Like the toys that I mentioned, but for example, this is also used in trauma therapy. And if you could use the robot there, that would be really nice. And also there are some children that are really interested in technology, for example, with autism, but not necessarily. In these cases, I think the robot could be really helpful as well to give something new and exciting to the treatment for the child.
Okay, So I see no more questions. Then maybe I propose to go over to Michiel. Are you ready, Michiel? How do you pronounce your name? You're muted. You're not muted.
It's Michiel.
You. We hear some clicks though.
Oh, and is this better?
Yes, now we hear something.
Okay,
or I
great.
hear something.
Okay, so it's Michiel, but it's a little hard to pronounce for non-Dutch speakers.
Michiel?
Yeah,
Okay.
that's right.
Okay, so Michiel is a lead software architect at AFAS Software, and he's an external PhD student. So how many times a day are you in the office?
Well, since March, none.
But so, you're partially paid by university and partly paid by the software.
No, I'm fully paid by AFAS, and I do the research partly in my own time and partly in the company's time.
I see. Okay. Then yeah, so you talk today about low-code development platforms, and that's your PhD topic.
Yes.
Yeah, please go ahead.
Okay, let me share my screen. That is working, if I'm right. Yeah, okay, great. Yeah, so thank you for coming today. And I want to discuss the PhD research that I've been doing the last 5 years. Evolution of low-code development platforms in software ecosystems. It's research being carried out in the AMUSE project, which is a research project between University Utrecht, de Vrije Universiteit Amsterdam, and AFAS Software. And I'm the external PhD candidate that also works at AFAS Software. Before we dive into the results of the past 5 years, I want to explain some concepts to make everyone familiar with the research. So a low-code development platform is an application development platform that supports rapid application development using a declarative high-level programming abstraction. And key in a low-code development platform are the citizen developers, which are people not trained in software development, but whom through an LCDP can nonetheless build software applications, something that's becoming more popular in industry, and something that we want to encourage and improve. So a software ecosystem is a set of organizations collaboratively serving a market for software and services, a research area that the group organization and information is focusing on. And finally, an important software evolution law, applications that do not evolve in response to changing requirements or changing technology become less useful. Those concepts together bring me to the goal of my PhD research, which is to improve the evolution of applications built with low-code development platforms to enable citizen developers to build ever more advanced software systems, such as software ecosystems. And the research that we've carried out in the past years has focused on 3 main areas. The first of them is the data area. So software applications have data that they store, and that data needs to be evolved during the evolution of an application. And what we've done in the research is we focused on event sourcing, which is an architecture pattern that not only stores the last state of an application, but stores every state change that happened in that application. That's an architecture pattern that's becoming more popular in cloud-native applications, event-driven architectures, and which is not yet fully researched. And what we've done is we've produced a framework for practitioners and engineers to guide them in upgrading their system by letting them choose the technique that they could use and to decide upon benefits and liabilities, which is the most fitting technique for them. In follow-up research, we've interviewed 25 engineers who have experience using event sourcing, And what we've done is we've summarized them into different categories. We've summarized the rationales that they use to use event sourcing that they have. And we've also matched them with the techniques that we've provided in the framework to give other practitioners a more grounded way of deciding what the best fitting technique is for them. So this is the first area, the data area. The second area that we've researched is the architecture side of a low-code development platform and how we can improve evolution from that perspective. And in this research, we've done a literature review and a survey among low-code development platform providers. And we've developed a framework in which they can decide how to execute the model that's used in the low-code development platform. So often the goal of low-code development platforms is to provide a citizen developer with an abstraction to create applications. That's often done through model-driven engineering. And there are different ways to execute the model that's created. It could be through code generation or through interpretation. And what we've done is we've matched those approaches with different quality attributes. And we've created a framework in which an architect or a practitioner can decide what's the best of the most fitting approach for their architecture and the quality attributes that they're after. And then finally, we come to the ecosystem area. And in this area, we've focused on how ecosystems and mainly the APIs that are used within an ecosystem can be evolved from a low-code development platform perspective. And again, we're in the middle of two research projects in this area. The first is that we are building a maturity model for API management. And this maturity model will give engineers the tools for API management maturity. And it will give them a roadmap on which capabilities they need to improve. And APIs are central in an ecosystem for the complementers to build add-ons to an application. So this improvement of API management is crucial for an ecosystem to flourish. And then from that maturity model, we've developed an evolution model for low-code platforms in which low-code platform providers can see how well they are suited to build ecosystems. So this gives low-code providers means to evaluate themselves and see what they need to place on a roadmap in order to improve their platform for the citizen developer so that they can serve their customers better. So together, these three areas will improve the evolution of applications built with low-code development platforms. And from there, we can enable citizen developers to build ever more advanced software systems. And that's the goal of my research. Thank you for listening. And if there are any questions, feel free.
Okay, bedankt Michiel. Yeah, so again, you can ask questions by hand or just go ahead and say something. Yeah, so for me, it's I've not heard of these low code and citizen developer, but so the way that I imagine it is something like Lego systems would be something where you can, program your robot that you built with Lego, and you do like some drag and drop,
yep.
and then you have some lines of code that you can write here and there. But I mean, you say that you want to enable someone to build larger software systems. Now, when I think of Python, I today had a random coffee break with Jira, and he said, well, as soon as you go to larger projects, Python is already maybe not necessarily suitable because it is just software needs to be structured, right? You need to have concepts like objects, you need to have types, you need to have, you need to know something about how to modularize your software. Yeah, now your system supposedly is easier than Python, right? And Python is like easy for, like, my students always say, I write pseudocode because Python, that's pseudocode already, like, right? Now, okay, now I talked a lot, but my question now comes, like, to where can this go? I mean, do you have the next Google Maps using Lego systems, or?
Also, what we experience in the research is that most low-code development platforms focus on business applications. So they are in the finance or business automation, those kinds of applications. And what you see is that those low-code platforms, like for instance, a Mendix or an OutSystems, are growing up and are becoming more common within enterprises. And exactly the problem that you discuss is that those applications tend to grow because, like every software system, features are added, and the management becomes harder. And that one of the trends that we see with their local providers is that they start to split up applications into smaller sub-applications, but then again need to integrate those applications. And that's exactly, for instance, where the API management becomes crucial, because the integration happens with API management tools. But those API management tools need to be citizen developers so that they can integrate applications more on a business perspective and not on a technical perspective. So Python is technical, and you can expect Python users to dive into technical details. But in low-code platforms, you need to raise the abstraction level so that a citizen developer is not worried about HTTP, for instance, or authentications. But the low-code development platform needs to abstract that away, and that's the challenge.
Yes. Okay. That makes sense. So how easy does it get? So you would expect a user to have a technical, let's say they studied physics or engineering, but not necessarily computer science. Is maybe that's what I should have in mind.
Yeah. So the typical citizen developer is something that's skilled in his own business domain, but not in the technical domain, in the computer science domain. Okay. But we still need to enable him to automate some task from his own domain.
Okay.
Yeah, I have one question. I use these low-code apps some time ago, and well, when I noticed when I was building some app with all those blocks that you mentioned, well, at some point you still want to make some adjustments to some of those blocks to you get what I mean. What is the flexibility of those blocks, and to which extent can you start up with those large blocks and then you need to adjust them sometimes, isn't it?
Yeah. So that's something indeed that we that's something that we see in this research. So we interviewed 3 low-code providers on their or 4 on their vision and how they see the market, and most of them still see more co-development between professional developers and citizen developers. And in that co-development scenario, the professional developer will create a block or will extend a block, and then we'll give it to the citizen developer to go on and build applications with them. I would say personally that the end goal should be to give the citizen developer the full power, but of course that's it's a long stretch. There's a long tail of details that you need to cover, and sometimes it's cheaper to give the way out to a professional developer and customize something. But all low-code providers that we interviewed also see the risk of that extension. because at the moment that you give an extension point to a professional developer, it starts to mess with your abstraction and lose control.
Yeah, exactly. So that's my point. How do you make those apps fit your needs, but at the same time make them so to such extent as extractive, so that you can make more of them or more of them the same way. I think that is a difficult balance.
Yeah, and super interesting research indeed on where the balance is. Yeah.
I would have another question. So what about I am always embarrassing myself, but I have very little programming experience, and I work in a computer science department. People are usually confused about this. And they say, oh, but you should learn, you should just spend a year on learning Python. I'm like, guy, I don't have time for this, right?
Mm-hmm.
It's not, it has nothing to do with my daily job. It's like, I also meet people in algebra. They tell me, you just studied 2 years algebra and then you know everything. I'm like, I can't do all of this, right? So I guess this is where this citizen developer comes in. Let's say I want to program a nice app for Android or something. Is that something suitable for me? What platform would you recommend?
So I don't have any clear.
Or is this dangerous for you to get?
I have no clear recommendations of platforms, but there are several platforms that indeed support the creation of mobile apps, and for instance, indeed Android apps. So there's a long list of different platforms, and some platforms are more enterprisey minded, and some are more mobile easy minded. So I don't have any clear recommendations.
Can you tell me some name?
Sorry.
Give us some names.
So the more enterprise focused Mendix, OutSystems, Pegasystems, those are the older and more traditional enterprise aimed providers. But you also have for instance, ThinkWise, BettyBlocks, which are some Dutch providers. There are more technical providers. Servoy is an original Dutch one that's now been international. But I don't have any clear mobile because my research is more focused in the enterprise. I'm looking at Slinger, my co-promoter. Maybe he has some name for the Android market.
Yeah, I have the same problem. I know mostly the enterprise systems, but I was thinking about MIT App Generator, if that is still active. But I only used it maybe 10 years ago, so it's a long time ago already. Yeah. But I know there's some app generating apps that currently exist, and it's very cheap to create an app these days. But of course, the moment you want to do something really funky, like build a game, or then you need a more domain-specific model-driven engine. And we are in the enterprise domain, so that's for us. It's all about scalability and evolution in software ecosystems, and those are mostly right now in the enterprise domain.
Yeah.
Okay, I see that we have a question from Gerhard. I probably mispronounced
yes,
the name.
Thank you. Thank you for your presentation, Michiel. As Till is about to engage himself as citizen developer, that's what's about to happen, I guess.
Yeah.
Makes me at least reflect a little bit on the role of the citizen developer, or better said, the competences of a citizen developer. Being a little bit older, parts of this discussion remember me of a previous one, when it was once stated that since we have SQL, you don't need database knowledge anymore, and anybody can write database queries. We could reflect on this as well, but let's take it to this point. How citizen can you be to still become a citizen developer? When can you really get involved, would you say? It's a bit outside the scope perhaps, but it still is interesting, because in a broader sense, who can participate in the ecosystem this way?
Yeah, so if I'm understanding your question correctly, you're asking what's the entry point of citizen developers? What's the minimal?
What do you expect from them?
Yeah.
Can it be taught on primary school?
So that's an interesting question. And again, what Slinger mentioned, it kind of depends on the domain where you're in, because we are in the enterprise. So I would say someone that's skilled in the enterprise domain, like finance or project management, would there be the entry point. And some you could say that, for instance, Excel and Microsoft Access used to be a low-code development platform, because you can build a system with it without programming knowledge. Well, Excel formulas is already can become quite complex, but those are in some sense low-code development platforms. So in that sense, you would say in a more business environment, the most common knowledge of ICT kind of environments is enough. But if you translate this indeed to a domain that's more aimed at, well, for instance, primary school kids with Lego Mindstorms, well, you could say that that's the lowest, and that's the entry point. Lego Mindstorms is something that I teach to primary school kids, and we have experience with ages 10 and up. In teaching them programming with a robot. And the interesting thing is that the robots can talk with each other, and you could create an ecosystem of different robots talking to each other and cooperating. I think the real communication is too complex for 10 years, but letting a robot drive around is something that 10-year-old kids could master.
Okay, so you really say it's about domain knowledge. Yeah.
And I think that's the crucial role for the citizen developer. It should be about his domain knowledge, okay, and not about the technical aspects.
Okay, clear. Thank you.
You're welcome.
Okay, I see that there are no more questions. Then let us thank again all the speakers, and thanks everyone for coming. Okay, bedankt Anouk, bedankt Michiel, en doei en tot volgende week.
Okay, bye.
Bye.
Bye bye.